Hello, everyone, and welcome to Science Explorations. My name is Ella, and I want to introduce Sarah, who's joining us today from WonderLab as well.
Hi, everyone. It's good to see you all again, and if you're new, I'm glad you're here.
Perfect. Thanks, Sarah. So Sarah and I are from WonderLab Museum in Bloomington, Indiana, and we are here today for a program we call Science Explorations, where we talk about a topic and we do some experiments that you can do at home. Has anyone heard of surface tension? Any ideas what that might be? So you can answer that in the chat. You can raise your hands like this. You can raise your hands in the participant area. Yeah, that's exactly right. Adam, is it? Surface tension is exactly right. That's what makes when you fill a cup really, really high with water, that's what makes kind of bubble over at the top. So surface tension happens because water molecules are attracted to each other through a force called cohesion, and they make the top of, say, a cup or a bowl, they make it really, really strong and thick. And that is what surface tension is. And so we're going to do a bunch of experiments today involving surface tension, and you can try all of these at home if you want. So for our first experiment, I actually have exactly what Adam just described. I have a cup of water, and I've got it pretty full here, but I'm going to add more water in, and we're going to try to see that curve over the top. Okay, so now I think I've got enough on top.
Ella, would you like me to show a video? Ella created a video of this,
Sure.
that wobble up top, or what somebody earlier commented was the cupcake of water over the top of the cup. So I'm going to share my screen with you all really quickly, and I'm going to show you that wobble. Can everyone see that wobble over top? There's just a little curvature over the top of the cup.
So now that I have filled it up all the way to the top, we're going to try an experiment. I found some paper clips, and I'm going to try to add paper clips to this cup of water. Now we know that the water is already at the top, right? We can see it. We can see the curvature of the surface tension. So what do you all think will happen if I add paper clips to this cup? So again, you can answer in the chat. You can raise your hands to your camera like this. You can raise your hands in the participant area. Do we see anybody, Sarah?
I'm so glad to hear that.
It's so great. I'm glad you're going to do the experiment with us. I see in the chat we have some guesses that it will float. Some people think that it will overflow. Oh, quite a few think it will overflow. Okay, so we've got some guesses that they're going to float on the top. Some think that the whole glass is going to overflow. So let's just see what happens when I put in a paperclip. Very cool. We can see it down in the bottom there. Sank to the bottom. So now that we know that the paper clips will sink to the bottom, let's see how many we can fit. Any guesses? How many paper clips we can fit in my very, very full cup of water with billowing surface tension at the top?
Somebody named Sarah has had their hand up for a long time. Another Sarah.
5 paper clips until it overflows. You know, I see some people in the chat agreeing with you. We've got, let's see, Delaney guessed 10, Renee 5, Brooklyn 10, Emma 5. Ooh, Alice 8 says 500. Some think it's gonna overflow at 10. Okay, so we've got one. Let's keep on going.
All right, go ahead, Ella. And I'm gonna be tallying as Ella counts, everyone. So we've already done one, and I'm gonna keep a tally so you'll be able to see on here how many it takes.
Thank you. So someone asked why we're guessing numbers. We are guessing how many paper clips will fit in this glass of water that is full to the brim. So we've already got one. Let's keep going. 2, 3, 4. 48, 49, 50. I see some guesses getting higher. 67, 68. Oh, and it started dribbling down the side. So 67 was the number.
I got it.
That was a lot. That was more than I got last time I tried that. Yikes. Those of you trying at home, feel free to comment how many you got. So I'm just gonna take a little water out so I can move that. Okay, so I've got another paperclip surface tension experiment to try with a new glass of water. So a lot of you guessed when I asked what would happen if I put a paperclip in the water, a lot of you guessed that it would float. And I'm wondering how we could make that happen. You saw me put 67 paperclips in the cup just now, and they all sink to the bottom, right? Why did they sink to the bottom? And how on earth could we make a paperclip float? Big and flat. Yeah, so I think, David, you were talking about something called the surface area. Like for those of you who have been to WonderLab, I bet you have tried out the bed of nails. And it's the same kind of concept. When you spread your body out, you make a bigger surface area and the nails don't hurt you. Versus if you scrunch up in a little ball, your surface area is smaller and the nails might poke you. So you're saying flatten out the paperclip. That would be a great experiment to try. I kind of actually did that here. This is a tool I use. It's a paperclip that I straightened out, and this is my tool for getting a paperclip to float. So you all can try this at home. All you do is take a paperclip and you pull out the middle to make like a little handle. Then you get another paperclip, dropped it right in. You set it on top, and then you gently put it in and it floats right in the water. Sarah, do you have a video of that?
I sure do. I'm going to share my screen with everyone so we can see that up a little more closely.
There we go. All right. So you can definitely easily recreate this at home. But now I have a question for you all. How might we get this paperclip to sink without touching it? So before, when we did our experiment with the very full glass of water, when I put the paper clips in, they sink right to the bottom, but I put them in with my fingers. I put this paper clip in with another paper clip, but how might I get it to sink to the bottom? You could push it down with another paper clip. Yeah. Yeah, so the reason they were falling down earlier to the bottom was the force with which I was putting them in. So you could add some force from another paper clip. Definitely. Thanks, Mara. Any other guesses? Maybe not adding force from our fingers or anything else? Oh, so stack the paper clips so it gets so heavy that it breaks the surface tension. We've got blow on it, push it down hard, take the water out, then it would definitely go to the bottom, wouldn't it? Okay, well, I'm gonna reach over here. I brought some dish soap with me. And let's see what happens when I add this dish soap to the glass. Did everyone see that?
That might have been kind of hard to see. Ella also filmed this, so I'm going to share my screen one more time, and we're going to watch how that happens. Here we go. All right, I'm going to show it one more time. Oh, we can't see.
Yeah, so it fell right to the bottom when we add dish soap. Dish soap is what we call a surfactant, which means that it breaks up the surface tension. I've got one final activity to learn about surface tension. So I'm going to lower my screen a little bit so we can focus on this pie plate. So right now I'm going to pour in some milk. You don't need very much for this. You just need to cover the bottom. If you don't have a pie plate at home, you could try this with really any kind of plate that curves up a little bit just so you don't have a milky mess. So now I'm just gonna add a little bit of food coloring. I'm gonna add a couple different colors. I've got my blue and my red. I'm gonna add a little yellow. Okay, fantastic. So you can use any colors that you want for this. Even if you have one color, this experiment is still super fun to try. Right now, all we have is a pie pan full of milk. The food coloring is not doing much right now, right? It's just floating on top of the milk because of the surface tension of the milk. So now I'm gonna bring in my dish soap once again, and I've got a chopstick here. You can use anything. A lot of people will use Q-tips for this experiment. You could use the end of a straw, a spoon, really anything you want. So I'm gonna put some dish soap on here. And before I do that, I'm wondering, what do you all think will happen if I add soap to this milk and food coloring bowl? Any predictions? So the colors are going to go to the sides. Let's see, in the chat, we have rainbow milk. We have Ani saying it will swirl around. Somebody saying it will become bubbly. Fun, because we're adding soap. Okay, so lower the screen so you can see what's going on again. I've got dish soap. Oh, I dropped it in already. It's going, it's happening. All right. So what is going on here?
Let's see, I've got some hands up.
Absolutely, the colors did mix together when the soap fell in the milk mixture. Thanks for the observation. So you think that the soap, when it was dropped into the milk, it's pushing the food coloring away? Why do you think that's happening? I see someone's written surface tension in the chat. It's pushing it out. I'm assuming that comment means it's pushing the colors out. The soap is pushing the colors out.
Go ahead, Ella.
Here, I'm gonna bring it back down because a lot more has happened and it's still moving. Yeah, so I'm gonna try to pull my camera a little bit closer so you can see. So I had some soap right here, here, and here. And you can see that there are sort of circles of colors around them. And that has to do with a couple things. Someone wrote surface tension in the chat, and that is why the food coloring wasn't automatically mixing with the milk. It's because of the surface tension of the milk. Now, I used whole milk, full fat milk, and that has a lot of fats and proteins in it. And when we add in the soap, the soap wants to bond with all of those fat molecules, so it goes chasing it, which is why you see the colors spreading out. And that's also why they're continuing to spread out. So you can do this experiment and set it aside and come back and you'll see some really, really beautiful colors. Someone asked, Diane asked, if the food coloring is only on top of the milk or is it mixed all of the way through? As, when you first add the food coloring, it's just on top because of the surface tension. But we know from our experiment where we dropped the paper clip to the bottom of the cup using soap, we know that soap breaks up surface tension. So I think it's fair to say that the color is mixed in now. I have another great question. Can you use other kinds of milk? So I mentioned that I used whole milk, full fat milk. What do you all think? Could you use other milks in this, other liquids? And if you could, why would you? Or which ones would you want to try? You can type them in the chat or you can raise your hand.
Somebody named Annie said, my family drinks 2%. Would that work?
Oh, great.
I recommend trying it out.
Absolutely. Yep. Try it out. Someone, Emma J, suggested chocolate too. Sure. Try it out. If you have a few different kinds of milk, try them all and see which one works best. So the reason that the dish soap is sort of chasing it around is because soap is made of molecules with two sides. One side that we call hydrophobic, that loves oils and fats, and one side that we call hydrophilic, that loves water. So when you put the dish soap in, it wants to find all of the fat molecules in the milk, and it's just going to move around. That soap's just going to move around so that it can find all of them. That's why washing your hands or washing your dishes works with like dish soap like this, Dawn. It bonds to all of the fats and the oils, and then when you rinse it with water, the hydrophilic water-loving side washes it all right off. So I am having trouble thinking of other liquids that would have like a high enough fat content. You could definitely try any kind of milk. You could try like coconut milk or almond milk or something like that. I think that sounds like a really fun experiment. Yeah. All right. Anyone have anything else they want to add before we wrap it up for the day? Let us know how your experiments go with all these different kinds of milk. You can post your results on our Facebook page, or you can email them to us at writeus@WonderLab. Great. Well, I think we're going to sign off for the day. Tune in. Have a good afternoon. Bye, everybody.